Hello guys, and welcome to the first video on my channel. So first I would like to announce what's going to happen on my channel. So I'm going to upload videos about anything school related or make educational videos. So the first video on my channel is going to be about naming compounds in chemistry. So naming compounds is a very essential skill to have, especially if you plan to work with higher level sciences including chemistry and biology. So yeah, we're going to be talking about the methods we use to name different compounds. So the first type of compound in chemistry is called an ionic compound. So ionic compounds are to do with charge, pretty much. So ionic compounds are made out of a nonmetal and a metal. So these usually occur when one atom either gains or loses electrons and passes it over to another atom, and they become charged, and then they stick together. So here's an example of how that happens. So one of the most common examples of an ionic compound is table salt, or sodium chloride. So sodium has one valence electron, only one. And what I mean by valence electron is the electrons in the outer shell of the sodium atom. So sodium chloride is made of one sodium atom and one chlorine atom. Now chlorine has 7 valence electrons, so we'll draw it like this, 2 on each side, like that. So how the compound forms is this sodium atom, it gives this electron over to the chlorine. So then what happens is oh, I forget to draw that. Alright, so this chlorine atom, it receives this and has 8 valence electrons, while this sodium gets rid of this and has 8 valence electrons from its inside shell. So what I mean by that is, since this sodium had 1 valence electron in the beginning, it had a shell of 8 on the inside. So when this sodium gave its 1 valence electron to the chlorine, it had a new valence shell sitting inside with 8 electrons. So after the transfer happens, this chlorine gains an electron, which makes it negatively charged, and the sodium loses an electron, which makes it positively charged. And one of the most fundamental laws in chemistry is that opposite charges attract, which makes these atoms attracted, which is an explanation for why they stick together and make a compound. Now let's talk about molecular compounds. Now molecular compounds are made up of 2 nonmetals. Now we never really see 2 metals bonding until we get later into metallic bonding, but for now we're just going to be talking about these 2 types. So molecular compounds, they don't have to do with charge. So what I mean by that is no transfer occurs in electrons, it's just 2 atoms which share electrons. So a common example of that would be water. So, okay, let me draw a water molecule. So water, as we know, it's H2O, so 2 hydrogen atoms and 1 oxygen atom. Hydrogen has 1 and only electron, which is its valence electron, and oxygen has 6. We'll draw it like that, just to fill in every spot of the 4 sides. Okay, so in molecular compounds, essentially what happens is this electron from the hydrogen is the oxygen feels it as a part of its own, so it's shared. So these electrons count as 4, but we count these 2 as part of the oxygens, and these 2 as part of the oxygens. So when we're counting, we count 1, 2, 3, 4, and we count these 2 and these 2 to make 8. But now we see how it stacks up for the hydrogen. Now for smaller atoms like hydrogen and helium, they only need to obtain 2 electrons to remain stable. So for the hydrogen, we have 1 over here, and we have 1 over there. And for the other one, there's 1 here and 1 there. So here we see that it's that each atom is completely stable, and the molecule will stay together. And the thing to note here is that none of these atoms have a charge, or retain a charge once the compound is formed. Alright, now let's talk about where these compounds exist on the periodic table. So for the example of the ionic compound, we use sodium chloride. So first we'll find sodium, that's over here. I'll choose a different color. So sodium, that's over here. And chlorine is over here. Chlorine, chloride. Alright, so ionic compounds tend to form when the atoms are on different sides of the periodic table. So we can see that the sodium atom and the chlorine atom are very far away on the periodic table. And to understand why this happens, we need to understand ions. So each atom tends to gain or lose electrons to have 8 valence electrons in its outer shell. So as we said in the previous example, where we saw the chlorine atom having an extra electron to have 8, when we saw that transfer of electrons, this is called the octet rule, where atoms gain or lose electrons to have 8 in their outer shell. So to determine the ion that each element produces, we can use the properties of a noble gas. So these noble gases over here, they all have full outer shells, full valence shells. So what that means is that they have 8 valence electrons except helium. And as I said before, hydrogen and helium, these two compounds, they only require 2 in their outer shell. So disregarding that, we'll say that these all have 8. And 8 is the desired number for these compounds. So to determine the ion that an element produces, we have to start counting from this area over to the element we want to determine. So to determine the ion that sodium forms, we have to take a look at sodium and find the nearest noble gas. Nearest noble gas to sodium, remember we can go forward or backward, is neon. So we can start at neon and then count forward to sodium. So to count to sodium, we have to go forward 1, we have to go up 1, till we reach over here. Since we go up 1, sodium forms a positive ion. And now for chlorine, the nearest noble gas is argon. So we start at argon, and then count back 1 to chlorine. So -1. So we can say chlorine minus. What I mean by minus is there's an implied -1, but I'm just going to leave it as minus. And that works out with the example we saw before, because we saw the sodium transferring an electron to the chlorine, which means it loses negative charge. Since the electrons are negatively charged, it loses negatively charged electrons, which makes it positively charged. And since the chlorine gains negatively charged electrons, it becomes even more negatively charged. So now we can see why ionic compounds are so far away on the periodic table. So now let's talk about how to name these ionic compounds. Ionic compounds consist of a cation and an anion. So how we name them is we make the first word the cation and the second word the anion. What I mean by cation is the positively charged part of it. So for sodium chloride, that would be the sodium. And for anion, I mean the negatively charged part of it. So how to remember this is in the word anion, we see this an. So you can kind of make it out to be a negative ion. That's just a way I found useful. So now let's try an example. So here we have KCl. Now hopefully you know your elements, and you know that this is potassium. So what we have to do first is find out what ion this produces. So if we go back up to our periodic table, we see K over here. So now what we have to do is find the nearest noble gas. And the nearest noble gas is argon back here. So we'll start there and count 1 over to potassium. So we counted 1 over, we can establish that it is +1. We counted 1 over. Now for the chlorine. Chlorine. Now for the chlorine. This is the chlorine. Now we have to determine what charge that is. So we see chlorine, and the nearest noble gas is argon, same as before. So we'll start at argon and count 1 back. And since we counted 1 back to reach, it's -1, the charge. Minus. That's chlorine. Alright. So what we do, as we said before, we put the cation first. So we already know what that is. That's potassium. And then we put the anion. But for this, and for most examples, you'll have to put an ide back here. So instead of chlorine, we'll say chloride. Alright? So that's the first example we did. Now for this example, we only had one element as the anion. But in more examples, we'll see that this anion can actually be made up of multiple elements. It can be polyatomic. So we'll look at that later. But right now, we're doing monatomic ions, or anions. Alright, now for another example. Here we'll try, let's see here. Okay, magnesium fluoride. What we want to do here is convert the name into the formula. So how we do this is, first of all, we have to find the ions that they tend to produce. So for magnesium, we'll go back to our periodic table. We look at magnesium, find the nearest noble gas, neon, and count 1, 2, over to magnesium. So from that we can conclude that magnesium's charge is +2, or 2 plus. Now for fluoride. Now for fluoride we can say that it's fluorine, of course. So we'll go back here, and then see fluorine, and neon is closest to it, and we have to count 1 back. So it has a -1 charge. Minus. I'll just put 1 here for this example. So if we want to turn this into the formula of magnesium fluoride, what we have to do is a cross multiplication trick, or not multiplication, a cross transfer trick, I'll call it that. So what we need to do is take the charge of these ions and disregard the sign of it, whether it's positive or negative. We just want the number for now. So what we have to do is take this number and move it down here, and take this number, move it down here. So we can take this 2, put it under the fluorine, take this 1, put it under the magnesium, and the formula we get is MgF2. That's the formula for magnesium fluoride. Okay, so there are a few cases where this trick is not what you want to do, and I'll cover that right now. So, okay, now let's talk about calcium sulfide. See this. Alright, so first of all, we're going to find the ions that each element tends to produce. So, for calcium, we'll find it on the periodic table, find the nearest noble gas, that's argon, then count forward 1 to potassium and 2 to calcium. So, we know that calcium has a 2 plus charge. Now, for sulfur, from sulfide, we find that on the periodic table, that's right here. So, from here, we have to count we have to find the nearest noble gas, that's argon, count 1 back and 2 back to get to it. So we know that this is a 2 minus charge. Now, from what I told you in the previous example, you think to move this 2 down here and this 2 down here. But in the case that these two are of equal number, you actually don't want to transfer anything and just leave it as the 2 elements. So this will be your formula, CAS, because these 2 numbers cancel each other out. It's just going to be with 1 and 1. Alright, now we're going to cover polyatomic ions. Alright, so here I have a list of polyatomic ions. So what I mean by polyatomic is poly meaning many, in this case more than 1, and atomic obviously meaning atoms. So here, polyatomic means many atoms. So this list of polyatomic ions is pretty much the most common ones, courtesy of Khan Academy, and you may have to ask your teacher for the ones you may be tested on or need to know for your class. So to name these compounds, we have to make use of this table to effectively name the compounds. So, as an example, we'll try potassium nitrate. I'll do that down here. Okay. So as an example right now, we will do potassium nitrate. Potassium nitrate. Okay. So, first we have to figure out the ion for potassium. Now, we did that before, but I can do it again. We find the closest noble gas to potassium, that is argon, and we have to count 1 over, back to here. So potassium has a charge of +1. There, right there. Now for nitrate, we have to look at this table, which in most classes you have to memorize these. So for this table, nitrate is defined as NO3 with a -1 charge. Now keep in mind that it's not just the oxygen which has a negative charge, but it's this whole thing. So this whole thing has a negative charge. So now we do the same crossover trick as before. One here, one there. So we'll move that over. Or no, one here and one there. But now we notice that these two cancel each other out. So when they cancel each other out, remember the rule before? We just leave it as it is. And it's KNO3, potassium nitrate. Okay, now we're going to try another example. Now we're going to try calcium hydroxide. Okay. So, first we're going to figure out the ion for calcium. And we go back here. And we see that calcium, the closest one is argon. So from argon is 1, 2, and 3 over to calcium. No, I'm sorry. From argon, it's 1 and 2 over to calcium. So calcium has a charge of 2+. Now for hydroxide, we're going to look at this table, which you should memorize. And this table should tell you that hydroxide is defined as OH minus, with the whole thing being negatively charged. OH minus. Now there's a 1 here. So now we can do the trick again. Move the 2 here, move the 1 there, because they're not equal. And we're going to say CaOH2. Now a common mistake which people do is that they take this 2 and distribute it out, and they make it CaO2H2. Now this, in most teachers, in most classrooms, will be marked wrong. So what you actually want to do is to leave it like this. And why you do that is you give the user, you give the reader an indication that this is actually a hydroxide. So if you're given this, it'll be much harder to work out if it's a hydroxide, rather than being given the one above here. So this is the correct formula for calcium hydroxide. Okay, now we're going to move on to molecular or covalent compounds. So one important thing for your test or quiz, I really think that's important, is that you get this table down in your head right here. Okay, this will be available on Khan Academy. I will put a link to that in the description, so feel free to check that out, print it out, make a Quizlet, and yeah, just memorize this. And also make sure you're aware of this, that there are positive polyatomic ions. Most people overlook these, but these may be a good thing to know for your test or quiz. Okay. Now we're going to be talking about molecular or covalent compounds. Now, these I've heard are much easier to name, and all you need to know are these prefixes. So, I'll start writing down the prefixes right now. So these are pretty intuitive, if I say so, because some of these you may know before from just using normal words, and you may have heard of these before. So cut. Okay, now let's talk about molecular or covalent compounds. Now, for molecular and covalent compounds, you need to know this set of prefixes over here. So most of these will be very intuitive to you, maybe because you used them in words before, like tricycle for 3 wheels, yeah, like hexagon for 6 sides. So just one thing to keep in mind, this mono prefix, it can actually turn into mon if the next word already begins to with an O. So yeah, just one thing to keep in mind. You don't want to repeat it. So first we'll start off with an example of a molecular compound. And then I'll introduce the rules for them. So first we'll start off with this one. Okay. So the first element over here is xenon. So how we name this is we still use the same two words, which will be the first one and the second one. So for this one, we're going to write xenon. And since there's two, we're going to have to pick the prefix. The prefix for this is di. Di. Let me make that capital letter. Di. Now, for this element, which is fluorine, we're just going to write fluorine. Oh, sorry, fluoride. Keep that in mind. For both ionic and molecular, you want to add an "ide" ending. Something I forgot before. "Ide." Unless it already has an "ide," you want to add one. Or if you're using a polyatomic ion for ionic, you don't need to add an "ide." So since there are 4 fluorine atoms, we're going to choose the tetra prefix. Tetra. And our final name would be dixenon tetrafluoride for this formula. So yeah, as you can see, this is much easier than before. But one rule to keep in mind is this is all about this first prefix over here. This prefix can only be used for the second one. That's all that you need to know. So let's try another example. Let's try this. CO. So we'll set up our blanks here. Let's try that again. Got it. Okay. So this first element is carbon, as we know, carbon. And since there's one of it, we look to the table. But wait, remember what I said before about this prefix for 1 only being applicable for the second element in the compound? So for the carbon, we actually don't use a prefix. We only use a prefix for 1 in the second part. So we just leave it as carbon. And for the second element, we have oxygen, which also has an implied 1. So we look to the table, and for the second part, we're allowed to use all the prefixes. So we're writing oxygen, but instead of writing oxygen, remember that we have to add the "ide." So I'm just going to write here, oxide. And remember to choose the prefix. And since this already begins with an O, we don't want to use this prefix. We don't want to add 2 O's for monoxide. That would be weird. So we just write monoxide. So this is the name for CO, is carbon monoxide. Not monocarbon monoxide. That is wrong. So you guys just learned how to name molecular ionic compounds. So if you enjoyed this video, be sure to leave a like. Let me know in the comments anything I can improve on. But yeah, I am a little bit sick now, as I said before. So hopefully my voice will sound a bit better soon. But if this helped you, please let me know. And yeah, that's it. Bye, and thank you for watching.